Hey, y'all, let's cover GCF, grouping, and factoring trinomials. Now, this is the part one for this section, and it's the greatest common factor. Greatest common factor we're using GCF for. That means largest factor common to each term in the given polynomial. So what I like to say instead is what does or what do all terms have in common? So what does or what do pick a verb. Uh, what does all terms have in common? And whatever that common thing is, we factor it out. So, as an example, it says write the GCF out in front of the parentheses and divide each term by the GCF to obtain what goes inside the parentheses. So this is what that means. If we take 10x plus 30, and you should be able to see that 10, each term, this is a term and this is a term, each term has 10 in common. So what we're going to do is we're going to divide out 10 from each of these terms. This is what we're doing, but this is not how we show it. How we show it is this. We factor out a 10, and when we do that, this reduces, and we're left with just x for the first term. When we factor out 10 from the second term, we're left with 3. Now, the way to check this is to go back and distribute that 10 back in. 10 times x is 10x. 10 times 3 is 30. So that means this is the factored form for 10x plus 30. Let's look at B. What did these two terms have in common? They both have an x. So I can factor out an x from each one. If you think of it this way, we're dividing both by x. But we're going to write it like this, x, and we're factoring it out. When we factor out x from x squared, we're left with 1x. When we factor out x from 5x, we're left with 5. Again, you can check this by factoring back in. X times x is x squared. X times 5 is 5x. So that looks exactly like the original, which means we have factored it properly. Pause the video and attempt this one yourself. What do they have in common? Factor it out. And when you factor it out, what are you left with? Okay, they both have 8 in common. So I'm going to factor out an 8. And when I do that, I'm left with y minus 1. So 8y, 8 times y is 8y. 8 times negative 1 is negative 8. So that works properly. All right. The next one. Ooh, let's get rid of that light. There we go. So it looks like they have what in common? So I want you to always pause the video and check this yourself to make sure you can do this while you're working with me or while I'm here to support you. So they have 5y in common. I can factor out a 5y, and when I do that, I'm left with y squared plus 2. So 5y times y squared is 5y cubed. 5 times 2 is 10. And don't forget the y. So it looks like the original. Therefore, we are factored out. All right. What did we have 3 terms now. What do they have in common? Well, I see they have an x, but we need a number as well, probably. Let's see. 9. Well, 9 doesn't go into 12, so it can't be 9. How about 3? 3 goes into 9, 3 goes into 12, 3 goes into 24. So whenever I factor 3 out from 9, I'm left with 3. Factor x from x to the 5th, I'm left with x to the 4th. Minus 3 goes into 12 4 times. Factoring out x from x cubed leaves me with x squared. Plus 3 goes into 24 8 times. And we've already got the x represented. All right, can check that by distributing back in. 3 times 3 is 9. X, remember there's a 1 up here. When you multiply your bases, you add your exponents. So 1 plus 4 is 5. Minus 3 times 4 is 12. X times x squared, 1 plus 2 is 3. And then 3 times 8 is 24. Don't forget the x. So this looks great. All right. This one looks a little hairy. Why don't you pause the video and give this one a try? Like a little puzzle here. All right. I know 3 goes into each of these, but it looks like 9 does too. I think 9 is going to be my largest number I can pull out, factor out. 1x and 1y. And when I do that, 9 times 3 is 27. We've got 1x, but we need a second x. We've got 1y, but we need 2 more. Minus 9 times 2 is 18. Already got it to x, and then we need 1 more y. Plus 9 times 5 is 45. We've got 1x, we need 1 more, and then we've got the y taken care of. All right, you can check that by redistributing it back in. That looks right to me. Yeah. All right. Ooh, fun, 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 fun. Okay, we have 2 terms here. I know it looks like there's a lot of terms happening, but there's actually only 2. We've got this term and we've got this term. So between these 2 terms, what do they have in common? What can we factor out? They both have x plus 6 in common. And when you factor out x plus 6 from this first term, we're left with x. When you factor out x plus 6 from the second term, we're left with plus 4. You can check this in any manner you want. You can use FOIL, box, distributive method to check to verify that this is factored to give you the same answer back. All right. Actually, when you do that, it's not going to look like this. If you want to know, it's going to be x squared plus 10x plus 24 is what you would get back for this one if you check that. Sorry. All right, let's look at the next 2 terms. Why don't you try this one? Factor it out, see what you get left. Factor out the x minus 3 because that's what they have in common. And when you do that, you're left with 5x plus 9. Factoring out x minus 3 from the first term, you're left with 5x. Factoring out x plus 3 from the second term, you're left with plus 9. And that is your answer. Okay. The next one, you've got 2y, x plus y, minus x plus y. Now, if you're going to try this one yourself, which I highly recommend, you've got to realize and understand that when you factor out the x, let's just do it together. If you factor out from this term and this term, you factor out x plus y. What do you have left? When you factor x plus y from your first term, you have 2y left. When you factor x plus y from the second term, you don't have 0 left. You've got -1. There's always an assumed 1. So -1. Oh, now we've got 3 terms. Got 1, 2, 3 terms. This looks fun. Why don't you attempt this one? Come back to see how you did. The 3 they have in common, the 3 have in common x plus 2. When you factor x plus 2 from the first term, you're left with 8x to the fifth. When you factor out x plus 2 from the second term, you're left with negative 10x cubed. And when you factor x plus 2 from the third term, you have negative 2x squared. Hold the phone. We have more factoring we can do. But wait, there's more. Look at this. These are all even numbers. So I'm going to move this x plus 2 over here. It's still part of it, but I'm going to factor out something else. I'm going to at least factor out a 2 because they all factor by 2, and they all have x's. So what's the highest x that they have in common? X squared. So I can factor out a 2x squared from this. When I factor out a 2 from the 8, I'm left with 4. And when I factor out an x squared from x to the fifth, I'm left with x cubed. Remember, when the bases are multiplied, you add your exponents. So 2 plus 3 is 5. Minus 2 goes into 10 5 times. And I've got 2 x's, but we need one more. And then this one is negative, well, it's 2x squared. Well, you're not going to just not put anything here because this is a term that needs to be represented. So you're going to put a 1 because we've factored out the x squared. So it needs to at least be a 1. So I would rewrite this to put the 2x squared in the beginning. You don't have to. It's still correct. And that's your answer. All right, give me just a moment. I just wanted to make sure I knew where to stop for the video so that I only covered the specific information that we needed. So thank you for being patient. Factoring by grouping. This is not one I typically ever use, honestly, other than what we just did as far as factoring by grouping. This one's a different version, something totally different. So you'll notice that it's the same thing that we just did, but the issue is they've already factored up top for us. With this one, you're not doing that. Also notice you could combine these like terms, but they're wanting you to understand that you can take, so say this was x squared plus 15x plus 15. I'm sorry, I'm not doing this right. X squared plus 8x plus 15 is what this is. And they're wanting you to see that you can factor this out by separating that 8x into 3x and 5x. Here's my problem with that. Does it work whether I use 3x plus 5x and 5x plus 3x? So if it doesn't, that's where it can be confusing. So let's just check this. If I factor out, again, we're going to look at these two terms, and then we're going to look at these two terms. If I factor out an x, I'm left with x plus 3 from the first term. If I factor out a 5 from the second two terms that they have in common, that's x plus 3. All right. Looking at both of these terms now, these are two different terms. This is what we were doing prior to this. They had already gotten you to this point. So now we're going back a little bit further. If you have 4 terms, this is the proper way to do this. Okay. What do these two terms have in common? They have x plus 3 in common. And when you factor that out from the first term, you have x. When you factor x plus 3 from the second term, you have plus 5. But here's what I want to check. What if instead of having x squared plus 3x plus 5x, having it in this form, what if we had it flipped? What if we had these two in different locations? Will we still get the same answer? Let's check. Factor out from these two terms an x, and we're left with x plus 5. If you factor out a 3 from these two terms, we're left with x plus 5. Well, it's looking pretty good. Then we have the first term and the second term. So factor out x plus 5, and we would be left with x plus 3. Cool. Same answer. Fantastic. So it doesn't matter whether we have it either direction. All right, so then let's look at these first two terms and then these second two terms. In the first two terms, what do they have in common? They have an x in common. So we're going to factor out an x. And when we do that, we're left with x plus 7. Now, the second term here, we want it to be left with x plus 7. So we need to factor out something that's going to leave us with x plus 7 from the second term. We definitely need to factor out a negative because we don't want this to be a negative. And it looks like we need to factor out a 4. So negative 4 times x is negative 4x. Negative times the positive is negative. 4 times 7 is 28. So it looks great. Now let's look at these next two terms. We can factor out x plus 7. And we're left with x from the first term and minus 4, negative 4 from the second. All right. Now we've got, oh, nothing could have been combined here. These are just different beasts completely. So we've got our first two terms and our second two terms. Our first term has x in common, our first two terms, and that leaves us with y plus 6. All right. The second two terms have 2 in common. So when we factor out 2, that is y plus 6. Now we're going to look at the first term and the second term. What do they have in common? Y plus 6. And when we factor y plus 6 from the first term, we're left with x. Factor y plus 6 from the second term, you're left with plus 2. Why don't you pause the video and attempt this next one yourself, looking at the first two terms, what do they have in common that you can factor out? And then the second two terms, what do they? Do that, and then go from there. Okay, so for 10x, on this front page. So for 10x squared minus 12xy, well, there's definitely an x in there that I can factor out, but they're both even, so I can factor a 2 as well. 2 times 5 is 10. We've got 1x, I need one more, minus 2 times 6 is 12. We've got an x, we need a y. Okay, looking at the second two terms, I know they're both divisible by 7, because 7 times 5 is 35, and 7 times 6 is 42. So I'm going to factor out a 7 and a y. And that will leave me with 5x minus 7 times 6 is 42, and we need one more y. Now, looking at these two terms, they have 5x minus 6y in common. And when I factor that out, I'm left with 2x from the first term plus 7y from the second term. Ooh, this one looks fun. We're going to look at these in 2 terms each. Why don't you try this one? See what happens. Let's get rid of that light. There we go. What do the first 2 terms have in common? What do the second 2 terms have in common? And what do the third two terms have in common? Do that, factor it out, see what you have left, and then combine them. The first 2 terms have 7x to the 4th that I can factor out. That will leave me with an x minus 1. The second 2 terms have x squared in common that I'm going to factor out. That leaves me with an x minus 1. And then the third 2 terms have a 3 in common. So that leaves me with an x minus 1. Looking at these three terms, what do they all have in common? They all have x minus 1. When you factor that out from the first term, you're left with 7x to the fourth. Factoring it from the second term, you're left with plus x squared. And factoring it from the third term, you're left with plus 3. All right, that is it for this video. Let me know what questions you have.